diagrams. What is ray diagram? It is a diagram through which we can find the location, type and size of image. So let's know how to draw the normal to the circle. Suppose let's take the circle and we have to draw the tangent to the circle, and so this point, this is center of curvature, this point is, and this is the tangential point. The point at this on the tangent is the tangential point. This line joining between center of curvature and tangent point is radius. This radius is normal to the tangential line. That means the radius of the circle is always perpendicular to the circle drawn at any point. The line drawn from C to any point on the mirror gives the normal at that point. So this is a concave mirror, and we have to see this is the principal pole P and center of curvature C, and this is the principal axis, and the lines which are passing through the center of curvature are normal lines. Focal point. How to find focal point of concave mirror? So see this, let's take the concave mirror, and it's some parallel beam of light which are incident on the concave mirror. What happening? So the rays coming from the sun parallel to the concave mirror are converging at a point. This point is called focus or focal point of the concave mirror. Measure the distance of this spot from the pole P of the mirror. This distance is the focal length F of the mirror. So concave mirror is a converging mirror. That's why this parallel light beam is converging at one point on the principal focus, principal line, principal axis. So this point is the principal point or focal point. Principal focal point. Okay. So next one is the ray diagrams for concave mirror. What are the uses of ray diagrams? Ray diagrams are very useful to find the location, size and type of image of the concave mirror, either concave mirror or convex mirror. So R1 ray diagram. See, this is a concave mirror and P, F, C, and let's take the candle. One ray which is passing from the candle, which is parallel to the principal axis and reflecting through the focal point. So all parallel rays are reflecting through the focal point. This is very important. This is ray 1. So R1 diagram. A ray parallel to the principal axis passing through the principal focus F after reflection from a concave mirror. Okay. Next one is R2. R2 means again we have to consider candle, and one ray which is incident through the focal point and reflecting from the concave mirror which is parallel to the principal axis. That means it is very reciprocal to the R1 ray. In a ray passing through F becomes parallel to principal axis after reflection from a concave mirror. Okay. Next one is R3. R3 ray means there is a possibility to pass through the center. So already we find the lines which are passing through the center of curvature are normal lines. So that's why again we have to consider one candle, and this is R3. With if the ray is incident through the center of curvature, will get reflected back the same path in opposite direction. Okay. So why it is in the reflecting back in the same path in opposite direction? Because here angle I equal to 0 degree. So as well as if angle I equal 0 means angle R also 0. Angle R also 0 degrees, because this is a normal ray. So that's why angle I equal to angle R. At this position, so the ray is reflecting in the same path in opposite direction. This is the another possible ray diagram. Next, last possible ray diagram is R4. A ray passing through the sea is reflected back along the same path after reflection from a concave mirror. Okay, now last possible ray is R4. What is R4? R4 means we have to consider the candle, and there is a possible incidence at P. Suppose the light ray is incident at P, it will be reflected in it with the same angle and in the other direction. Suppose at this position a ray incident obliquely to the principal axis towards the pole P on the concave mirror is reflected reflected obliquely following the laws of reflection. Okay, these are the rays R1 ray diagram, R2 ray diagram, R3 ray diagram, R4 ray diagram. These are very useful to find the size of image, location of image, and type of image. Okay, thank you.